What if the moon just disappeared one night? You look up, and it's gone. No moonlight, no glow, just a dark, empty sky. At first, things might seem normal, but soon, strange changes begin. Tides misbehave, seasons lose rhythm, even the length of our days starts to shift. Some creatures are thrown off course, and Earth itself starts to feel unsteady, like it's lost a hidden anchor. For billions of years, it watched over us, shaping tides, steadying our axis, setting life's rhythm. We built calendars by it. Myths, migrations, civilizations rose and fell beneath its glow. The moon does more than shine. It quietly keeps Earth in balance in ways we barely understand. So, what really happens when it's gone? Let's start with a bit of Earth science. Earth leans at about 23.5 degrees on its axis. That tilt gives us our seasons. But this delicate balance isn't locked in place forever. If the moon suddenly vanished, Earth wouldn't start wobbling instantly, but its stabilizing force would be gone in a flash. The moon's gravity keeps our planet's tilt steady, and without it, Earth would immediately become vulnerable to subtle gravitational nudges from the Sun, Jupiter, and even other planets. At first, you wouldn't notice anything unusual. The tilt wouldn't shift overnight. But behind the scenes, Earth's internal balance would begin to unravel. Like a gyroscope that just lost its counterweight, our planet would be primed to drift, just waiting for the next push to send it tilting. Earth's tilt, called obliquity, could swing from nearly 0 up to around 45 degrees, causing extreme climate changes over time. It's kind of like removing the training wheels from a bike while it's still moving. You might stay upright for a while, until a bump throws everything off. So while the dramatic climate swings would take time to show up, the loss of stability would begin instantly. The moon doesn't just light up the night sky, it holds Earth's orientation in place. The moment it disappears, so does our grip on predictable seasons and stable weather. And with nothing to stop the wobble from growing, it's only a matter of time before Earth starts tilting in directions we're not prepared for. Now, you've seen the tides rise and fall, but here's what most people don't realize. 60 to 70% of that movement is powered by the moon's gravity. The sun helps too, but only accounts for about 30 to 40%. The moon is the main engine behind the powerful tides we see along coastlines around the world. Now picture this, the moon suddenly vanished. Tides wouldn't disappear entirely, but they would become significantly weaker, dropping to around 1/3 or less of their current height. Many shorelines would shift from teeming life to lifeless mudflats, starved of oxygen, nutrients, and motion. Mangrove forests, salt marshes, oysters, clams, crabs, and seabirds all depend on strong tidal motion to bring oxygen, flush out waste, and circulate nutrients. Without that constant movement, intertidal zones would break down, and the food webs built around them would begin to collapse. Local fisheries that rely on those ecosystems, especially in developing coastal communities, would be hit hard, and the effects ripple outward. Tidal energy helps power global ocean currents, like the Gulf Stream, which redistribute heat. Weaker tides could slow those currents, shifting weather patterns and rainfall across entire regions of the planet. And above all that, a darker Earth. Remove the moon, and the night sky fills with stars, but also a kind of darkness most of us have never known. It might sound peaceful, even beautiful, but for many species, it would be devastating. Sea turtle hatchlings rely on moonlight to find the ocean. Without it, many would crawl inland and die from predators or exposure. Certain birds, moths, and even coral reefs use lunar light and cycles to guide migration, feeding, and reproduction. Break that rhythm, and entire ecosystems fall out of sync. The moon has shaped human life too. Ancient calendars were built around its phases. Farmers used it to time planting. Sailors navigated by its glow across the seas. It helped us track time, mark seasons, and explore the unknown. Without the moon, eclipses disappear, both lunar and solar. These rare, awe-inspiring events sparked myths, guided rituals, and ignited scientific curiosity. Their absence would mark more than an astronomical loss. It would erase moments that connected cultures and generations. The moon is far more than a light in the sky. It's a natural guide, a keeper of time, and a quiet force that life on Earth has followed for millions of years. Remember that tilt we talked about? Earth leans at roughly 23.5 degrees, and the moon's gravitational pull helps keep it from drifting off course. Without the moon, that stability would gradually erode. Over long timescales, tens of thousands to millions of years, Earth's tilt could begin to shift unpredictably. Even modest changes of 5 to 10 degrees could dramatically reshape global climate zones. For example, a small increase in tilt would make summers hotter and winters colder in both hemispheres, especially at higher latitudes. Areas like southern Canada or northern Europe could see more severe winters, while regions near the equator could become drier or more seasonally extreme. Historical data suggests that even minor variations in Earth's orbital parameters helped trigger major climate events, like the African humid period, when the Sahara became a grassland roughly 9,000 years ago. Without the moon's steadying effect, such transitions could become more chaotic and frequent. In warmer phases, melting ice sheets in Greenland and Antarctica could raise sea levels by up to 5 to 7 meters over time, enough to flood low-lying cities like Miami, Jakarta, and Kolkata. Without the moon, Earth wouldn't spin out of control overnight, but over time, the planet would slowly become a far less stable, less predictable place to live. And life relies on that stability. Nature runs on timing. From corals to crops, life depends on predictable rhythms, many of them guided by the moon. For example, many coral reefs time their spawning to the days following a full moon, responding to subtle shifts in moonlight and tidal patterns. A mistimed spawn can lower fertilization success and weaken entire reef ecosystems. Migratory birds, marine worms, and fish also follow lunar or seasonal cues. Without them, predators and prey fall out of sync. Farming depends on seasonal predictability too. Even a slight shift in rainfall patterns can shorten planting windows by weeks, as seen in regions like East Africa. Farmers rely on consistent cues for frost, rainfall, and temperature to grow staples like wheat, maize, and rice. If Earth's seasons were no longer stable, due to changes in axial tilt or disrupted lunar rhythms, agriculture would become unreliable. The result? Lower yields, greater risk of crop failure, and a food system that's harder to manage year after year. And what about us? Humans adapt well, but life without the moon would push us to the edge. Over time, the moon's gravity has slowed Earth's rotation. About 1.4 billion years ago, a full day on Earth was only 18 hours long. Without the moon's stabilizing pull, Earth's rotation could speed up again, possibly shortening days to 20 hours or less over millions of years. That matters. Our bodies run on circadian rhythms, roughly 24-hour cycles tied to light and dark. Shorter days would disrupt sleep, concentration, hormone levels, and long-term health. Society would need a full redesign: work hours, school schedules, lighting, even agriculture. Buildings might need new climate controls to handle more temperature extremes. And timekeeping, months, weeks, and calendars rooted in lunar cycles would lose meaning. Without the moon, the night would be darker, but more importantly, we'd lose the steady rhythm that has guided human civilization for thousands of years. Luckily, we don't need to start panic packing for Moonmageddon. Yes, the moon is drifting away from Earth, but only at about 3.8 centimeters per year. That's actually slower than your fingernails grow. At that pace, it would take billions of years for the moon to drift far enough to matter, and by then, the sun will be in its final act. So rest easy, the moon isn't going anywhere anytime soon. But just for fun, what if it did disappear? Could we build a new one? In theory? Fascinating. In reality? Not even close. To match the moon's gravitational pull, we'd need to launch something weighing over 70 quintillion kilograms. That's more than 170 billion times heavier than the International Space Station. We don't have the tech to gather that much mass, let alone launch it into orbit. And even if we could, which we can't, it wouldn't fix the problem. A man-made moon might reflect light or orbit the planet, but it wouldn't restore the delicate, interwoven systems Earth evolved with over billions of years. Some engineers have proposed lunar substitutes, orbital mirrors to mimic moonlight, tidal generators, or even space-based climate stabilizers. Creative? Sure. Effective? Not really. Because the real moon is more than a mechanism. It fits perfectly. It belongs to Earth's story in a way no machine ever could, and that makes it truly irreplaceable. So, what's the coolest thing you learned about the moon today? Was it the tides, Earth's tilt, or the fact that we couldn't even begin to replace it if it disappeared? Drop your favorite fact in the comments. We'd love to hear it. And if you're into science, space, and mind-bending what-if questions, be sure to like, subscribe, and tap the bell so you never miss a new video. Thanks for watching, and as always, keep looking up.